completing the square is used to solve equations, but it's also used to take an equation and write it in a specific form. And good news for you, we'll be using completing the square now about halfway through the year, and then come like April in chapter 10, we'll be using it again. So it gets equations in standard form, so it has kind of different equations we'll be working with throughout the year. But looking at number 5, Chelsea, the first thing you do to complete the square is take the 5 to the other side. Oh, I got 2 lines. And in the same step, to save yourself some extra writing, what else could you do in that same step, Chelsea?
You take out the 3.
Right, you can take out a 3. Why do it in 2 separate steps when it can be done at the same time? So take the number to the other side, pull the coefficient out. That's in front of the x squared. And it's just the coefficient, not the x. You're only taking the number out. X needs to be squared in order for you to be able to factor. So then the next step, Libby, would be
Define, we'll do negative 2 over 2 squared.
and that makes 1. Right. Okay, so then you place 1 inside the parentheses. But on the other side, Brandon, you add 3, which I think, as I was kind of getting at through the earlier 2 classes, a lot of students are forgetting to do that part. Because really, this 3 gets distributed to everything, and for it to be equivalent, like technically you have 3x squared minus 6x plus 3 on the left. So if you're adding that extra 3 on the left, you have to make sure you're adding the same number to the right. So that seems to be one of the mistakes that a lot of students are making, is just forgetting about that number that's in front. So that kind of changes then the problem on the right side, that number that you're creating would be different. So don't forget, if there's a number outside, you have to multiply the value you're adding inside. All right, so the next step would be then to factor. The whole goal of completing the square is so that we can have a quantity squared, and x squared minus 2x plus 1 factors as x minus 1 times x minus 1, or just x minus 1 squared. And then it's equal to 8. So at this point, we would probably stop once we are talking about a parabola, but the directions did ask you to solve. So Brandon, to continue to solve, you would
multiply by 1/3 sides.
or divide by 3, since there's just a whole number over here. So depending on what kind of number you're dealing with, if you have a fraction on the right, multiply by a third. If you have a whole number on the right, you could just divide by 3, but they mean the same thing.
And you get, can I put that in fraction form? So it's, can I put that in fraction form? 24.
Okay, yeah, just hold it. Because it is technically in fraction form.
Sorry. Easier to take the square root.
So take the square root. Maybe. It'll come. So you take the square root of both sides, because our goal is to get the x squared out of the problem. I feel like Apple Team.
Never seen this work for the other teachers.
No, I'm really good. Besides the end of the day, I must say that it's fine, except for this period. Okay, so take the square root of both sides. We end up having x minus 1. And then on this side, we have the square root of 8 divided by 3, which really can be looked at as the square root of 8, separate and the square root of 3. Every other problem that we've done has had a nice perfect square in the denominator. So it was the square root of 4 a lot of times. It was the square root of 9, maybe the square root of 16. But you could take the square root and get a nice number. In this case, you can't take the square root and get a nice number because the square root of 3 doesn't exist. But you cannot leave a square root in the denominator. It's considered unsimplified. Just like having a negative number left in the denominator is unsimplified. I mean, yeah, sure, it can be done, but it can still be simplified further. So Brendan seems to be really excited because I think he knows how this simplifies. Brendan?
Couldn't you just multiply the top and the bottom by 3 and then take the square root of 9?
Why 3?
Because 3 times 3 equals 9 and 9 is a perfect
So we're gonna multiply it top and bottom by the square root of 3. That's called rationalizing the denominator. So we did that last year way back in chapter 6. So to get rid of the square root, you multiply by itself. Because as Brandon said, when you take the square root of 3 times the square root of 3, you get 9 underneath the square root, and the square root of 9 is really 3. And then on the top, you're going to multiply the square root of 8 and the square root of 3, and you get 24. Nice job, Brandon. So rationalizing the denominator, and I know a lot of you are thinking, she never told us we had to do that. No, I didn't tell you you had to do that. Yes, we learned it last year, so it's fair game. It's just the horrible thing about like trading pre-calculus. It's just there's so much to remember. So Sabrina, what else can you do now?
You can take out 4 out of 24, and it will be 2 times the square root of 6 over 3.
Nice job. So the square root of 24, now that you have that square root up there, it becomes the square root of 4, the square root of 6, which makes 2 square root 3. How about 6 over 3? The 1 gets added, the plus or minus sign goes in the middle. So we have 1 plus or minus 2 square root of 6, and then divided by. Right.
For some reason, whenever I did it, whenever I multiplied by 1/3 on both sides, and apparently I already made it 24 over 3 before I even multiplied it by 1/3. I don't know why,
I don't know why either.
but it ended up working.
Any questions on this? So I think Brandon got it to work. Did anybody else get it to work? We got 1 plus or minus 2 squared 6 over 3? No. Brandon must have had magic fairy dust sprinkled in his head at his softball game. Golf match yesterday. Is there another question from the homework that you would like to go over? Sure. Alex, do you like completing the square and then Okay, remember the answers were sent through Remind, so please check your answers. We're going to be using completing the square today, so if you're not quite there, we're going to go through a couple more examples. No other questions? So if I don't get to check it at the end of the period, which I might be able to in here, I'll check it on Monday, for sure. Alright, so then in your packet, Katie already took yours out, you look ready to go. If you'll look at page 7, so we're going to talk about quadratic functions. That's the first section. And then pretty much the next sections just build on top of the previous section. Half of this chapter, actually I think 5 sections out of this chapter are polynomials. The last 2 are radicals. So a polynomial has a form that looks crazy with that a sub n x to the n plus a sub n minus 1 x to the n minus 1, and then it goes on forever. And then it goes down a1 x to the first, and then a sub 0. So that's the form of a polynomial, which looks really confusing. It looks weird. It looks long. But a polynomial has whole number exponents. So a whole number, values starting at 1, going to infinity. Can't be a fraction, can't be a decimal, cannot be negative. That's a whole number. So polynomial is like x cubed, x to the 4th, x to the 5th, x to the 100th. Those are all polynomials. This jazz up here, all of this notation, all it means is that your powers descend in order. Brandon, descend means? Yes. So you start with x to the 5th, then you'll see x to the 4th, and then x cubed, and x squared, and x. and then it ends at a constant. They will not be mixed up. If they are, you need to fix them so that they're in descending order. And it will make a difference once we start dividing. So polynomial, powers descend in order. For it to be a polynomial, the power has to be a whole number. And those are like the curves. So we'll be graphing those curves again. In the little chart, kind of shows you how a function is built, one based off of the next. Like so the first one and then the second one's based off of the first, the third one's based off of the second. So this little chart is just for you to kind of see how like a function expands and builds on the previous. The first one is just starting out with a constant function, like y equals 7. Like just a basic line, horizontal. And then we get a linear function by placing an x next to that 7 and adding a y-intercept. So now we have ax plus 7. By putting that x in, we now have a line that goes like diagonally increasing or diagonally decreasing. And then for our quadratic function, we essentially add an extra power, so just building on what you had before. So the x becomes x squared, but then we need those others to descend in order. So anytime you add a power, you get an extra letter, because now we have ax squared plus b goes with x, and then plus c with the constant value. That creates our parabola. So you could continue this chart. We could make a cubic function. We would have ax cubed plus bx squared plus cx plus d. So the letters just kind of increase as your power gets larger. That's just showing you literally like one function is created from the previous by adding that power to it. And that's with all polynomials. So we'll talk about the parabola today. A little bit of review about a parabola. Everybody loved parabolas last year, right? That was like the first hard chapter of Algebra 2. Chapter 4 test. Challenging. So with a parabola, the form y equals ax squared plus bx plus c, that's called general form of a parabola. There's also standard form, and there's also intercept form. We did all three of them. We're going to work with the standard and the general form, kind of going through those. So the first graph on the left says if a is greater than 0, then the vertex is a minimum. What would that graph look like? Just in general, what does a parabola look like if a is greater than 0? Alex? Yeah, just a u, and that u could be anywhere. It could be wide, it could be narrow, but it's a u that goes up. And because it's Friday, it's a very happy u. Friday with 20 minutes left of school is an extremely happy parabola. Probably has its tongue sticking out too because it's really exciting. So absolute value. A is greater than 0, the vertex, remember the vertex is that bottom part, that's called the minimum. It's chin. So then the next one, if a is less than 0, that means we'd have a negative ax squared bx plus c. That graph is Monday morning at 7:20. Very sad, because we're back. Gotta get through the week again. That creates our frown. The vertex again, this time it's a max. So when it opens down, it creates a frown. A graph that opens down is a maximum point of a parabola. So down max, up min. Down makes a fraction. Question? So to get the vertex, we also talked about the axis of symmetry. They kind of went hand in hand. A vertex and the axis of symmetry were pretty much together. Does anybody remember what the axis of symmetry is? Not how to find it, just what is it? Virginia? Yep. And it is the line in the middle of the parabola. So you have like the same x and y, or x point positive and negative. Sabrina?
Didn't he have to have it like be a dotted line?
It is a dotted line, yeah. So we'll put that up here because it's not actually dash dotted. It's not actually part of the graph, but we use it for symmetry to help us find a point that's symmetrical on the left and the right. Does anybody remember the little formula to find the axis of symmetry? There was a tiny little formula in x equals 4. Ooh, Grace. Nice job. I should keep marks down how many times Grace volunteers throughout the year. So x equals negative b divided by 2a is a tiny little form of a parabola that we use when we have ax squared plus bx plus c. Because the a and the b are in the problem. And we just took those numbers, we put them into the formula, and then that told us where that line was going down the middle of the graph. And that was pretty much the line of symmetry, the halfway point. The left and the right are the same distance from the line of symmetry. Look semi-familiar? The other form that we're going to look at is called standard form. So general form, this is general form. And then standard form. Standard form is actually the form that we graphed, like all those basic graphs in section or chapter P. And the basic graphs in section 1-3 that we looked at again, they're all in standard form because they all have an h and a k. A parabola has an a in front, the x minus h quantity squared, so that minus h says left or right. The plus k tells the graph to move up or down. So we've actually dealt with standard form in every function that we've had. So the 6 basic functions have all been in standard form. We're going to see if we can now create standard form from general form. But just a reminder, the vertex is hk when it's in standard form. Remember, always opposite of h. The axis of symmetry is x equals h. So the great thing about standard form is that you don't have to do negative b divided by 2a because you already have the form that tells you the graph shifts left, right, up, or down. So that's what we're going to look at today. Questions? A little bit of review of parabolas there. So if you flip the page, we have a quadratic function, 4x squared minus 4x plus 21. And essentially, like, these steps are what is asked of you to do for 5 problems for your homework. We're going to go over 2 together in class. You'll have 5 to do for your homework. So it kind of just takes you step by step what we're going to look for. The first thing says to write it in standard form. That's completing the square. So you complete the square to get a parabola in standard form. To start completing the square, I'm going to take out f of x and make it 0. Because we need it to be equal to 0 to move a number to the other side. We don't want to keep that f of x in the problem. So we'll take f of x out, we'll plug it back in the answer. But it's okay to just pull it out so that we can complete the square. So Cade, what do you do to complete the square? What's the first step?
You take the 21 to the other side.
Right, take the 21 to the other side. I like my number to be on the right. That's just a me thing. I like x to be on the left, my number to be on the right. It's OCD crazy, I don't know. Maybe some of you are like that as well. If not, you can put the number on the left. But I always like to have that number on the right side. So the 21, he said take to the other side. And Kate, what else can we do in the same step?
Take out 4.
Awesome. Take out a 4. So x squared minus x, the 4 was taken out. Again, if you'd rather see the 21 on the left because it's currently sitting on the right and you like moving things to the left, to the opposite, that's fine. All right, so the second step, Brandon, now that we have the 4 taken out, we would?
Take negative 1 divided by 2 squared, which would be 1/4.
So that's b divided by 2 squared, so he said that's 1/4.
And then we add 1 to the other side.
So even though there's a fraction, and your mind is immediately thinking, it's just making a zero problem with a fraction, it works out kind of nice, because when you multiply 1/4 times 4, because remember you pulled out a 4, you're actually just adding 1 to the other side, which isn't so bad having a fraction. The fraction is gone. So factoring x minus 1/2, because 1/4 is really 1/2 times 1/2. And then it's equal to negative 20. So our goal is to write this in standard form. We're not going to simplify it, so we're going to write it in standard form, which says we should have f of x equals a, x minus h squared plus k. That's standard form. How can we get what we have into standard form? Virginia? Yeah, move the 20 back over. Put an f of x back in front. So we're taking that 0 back out. We replaced it to help us complete the square. We're going to make that back into f of x. And the 20 now gets pulled to the rest of the equation. So we're just taking that 20 to the other side. So the reason that I don't want you to try and divide by 4 in the beginning is because that 4 is the vertical stretch of our graph. So this is actually a pretty narrow parabola because you're moving up 4 extra units. Your x value is being multiplied by 4 to give it that vertical stretch. So this graph would open up. It would have a minimum vertex. It would have a vertical stretch of 4 depending on the questions you would be asked. But this is standard form from completing this way. Questions? So underneath, finding the axis of symmetry and the vertex are really easy because it's done for you once it's in standard form. You just pull out the numbers. So the axis of symmetry is 1/2, and the vertex is, say it again, 1/2, 20. Oh, the work's done. You're just using the numbers that are in the problem. And then the intercepts, well, there's x-intercepts and y-intercepts. Y-intercepts are always easier to find. In this case, the y-intercept is no work whatsoever. You just have to remember where it comes from in the equation. Virginia, do you remember? It's not 20 because that's the vertex that tells us the graph is going up, but it's also going right. So it can't be 20 because that's the vertex. Again, no work. Chelsea, is it? It's not 4. That tells us that it's stretching. It's actually from the original equation. It's the c value. So that c value of 21, because if you plug a 0 in for x, you have 4 times 0 squared minus 4 times 0. They just go away. So the 21 is the y-intercept. So you're actually using the original equation to get the y-intercept because it's way easier to do it that way. And then the last thing we have to do is get the x-intercepts, which is what you did yesterday with completing the square, or 2 days ago. So taking this equation right here, just going to pull it down. Continue solving for x. So anytime you find an x-intercept, you're really solving for x. That's what solving for x means in any function. If it was equal to 0, you solve for x, you found the x-intercepts. So continue solving this. We stopped completing the square to get it in standard form, but now we'll work through finishing the problem so that we know what our x value is. Okay, so divide by 4. Take the square root of both sides.
You can't,
Why not, Brandon?
because you get an imaginary number.
You get an imaginary number. What do you think that means about the x-intercept?
It's a restriction, and it doesn't exist.
It doesn't exist. These x-intercepts do not exist because the vertex starts, this guy right here, at 1/2 20. And if you think about where 1/2 20 is, here's 1, we'll say this is 20. The graph is starting all the way up here. And the graph is opening up. So it can't cross the x-axis if it starts above the x-axis and also goes up. why there aren't any x-intercepts to find. Questions? So, a little bit of work, 5 problems that are like that. A little bit of work for 5 problems. We're going to go through another one together just so you feel a little more comfortable. Are there questions on that? So see if you can start the next one. So we have the quadratic function f of x, which changed to 0 so you can complete the square. Negative x squared minus 4x plus 1. So if we're finding the vertex, the axis of symmetry, the intercepts, we need to get it into standard form. So even though it doesn't say get it in standard form, that's what we're going to do so that we can find the vertex, the axis of symmetry, the x and y intercepts. So see if you can get this in standard form. Is there a coefficient that can be pulled out? Yeah, -1. So even though there's a 1 in front, there's still a -1. That -1 has to be taken out. Must be a +1 in front. So if you take a -1 out, that means we have positive x squared, positive 4x. So anything with x squared, positive 2, -1, must be factored out. And then we take the b divided by 2 and square it. So Michael, what number are you adding to the left?
You're adding a 4,
But on the right side,
a -4.
nice. So remember, the left has a -1 in front of those parentheses, so when you go to the right, you're really placing a -4. And then this is x plus 2 quantity squared, it's equal to -5. So standard form would be negative x plus 2 squared, and then plus 5. Just take that 5 back so that it's with the quantity squared. So right here is standard form. Questions? Eris, what is the vertex? And the axis of symmetry? And how about the y-intercept? +1, awesome, nice job. So those 3 things, we have the work finished. Vertex axis of symmetry uses the standard form, the intercept goes back to the original form. So look at that last +1. And then the x-intercept, we have to continue to do a little bit more work. So we're going to take that -1, this equation right here, continue to solve that equation. So divide by -1, which gives us now a +5, so we can take the square root of it. We couldn't take the square root when it was negative, but since it had a negative in front, we divide by it, we can take the square root. So we end up with -2 plus or minus the square root of 5. I'm going to be lazy, tack on a 0 at the end to make it an ordered pair instead of writing it a second time. But intercepts are ordered pairs. So the y-intercept, 0, 1. The x-intercept, a number, 0. No, you don't have to separate them and write them twice. Keep them together. Again, less writing. Don't need to write extra things. The last question underneath says, what's the direction of the parabola? A Monday morning parabola. This one goes down, creates a frown. It's a maximum graph. So you will be asked to finish graphing these for your homework. We would graph it, Eris said -2, 5. So I would place that up here. Didn't count up high enough. we would have axis of symmetry going down the middle. The y-intercept is at 0, 1. Remember the other symmetrical value, the whole goal of the axis of symmetry is that I can then take that point at 0, 1 and plot it on the other side of the graph, the other side of the line of symmetry. And we can connect them. We also have x-intercepts that we can calculate and plot those as well. Questions? So with your graph paper, if you want, you can do the whole problem next to the graph. Because the graph paper I handed out to you has like a blank spot next to it, so you can do that. We're going to go through the last question really quickly. It's not a lot of work whatsoever. So we just did a lot of work. This one is not much work. It says find the quadratic function with the vertex at -2, +2, and a point at -1, 0. So if you have a vertex, what does that represent? Chelsea? The h and the k. So hk. Chelsea, if it is -2 in the equation, it would be +2 for the h. The k is already +2, so that would go outside. What do you think you do with the point? Chelsea? Yeah, plug it in for x and y. So any point randomly on a graph is x and y. The vertex gets the special h and k letters. So y is 0, x is -1. The only number that we don't have would be representing the a value. So that's what you would be finding. So plug in the 4 values and then simplify. So -1 plus 2 is +1. When you square +1, you still get 1. And then get a by itself. So make sure you're doing the exponent part first. And then move the the 2 to the other side. So you get a -2. Lots of 2's. So -2 means it goes down. Chelsea said the vertex becomes a +2 when you plug it in. The k value was already positive. So that would be the other type of problem that you'll see really isn't a lot of work. Questions? So again, please follow directions for your homework. Is anybody interested in doing 35 or 39? 35 is like the big parabola problem. 39 is like this one here. Chelsea? Which one would you like to do, Chelsea? Do you mind doing the large? Thank you.